Hello everyone, this is Ashwini from Cheenta.com. In this video, I will introduce a little bit of graph theory with a fun problem. This was discussed in the Math Olympiad program for elementary and middle school children. Particularly this problem is from Math Kangaroo. Math Kangaroo is a recommended Math Olympiad for the young kids, like kids in grades 1 to 6. After that, you can take AMC 8 and there are other beautiful math contests. But up to grade 6, we recommend Australian math competition and Math Kangaroo. Okay, so this problem in itself, it's very simple and you really don't have to know graph theory to do it. But what we do is we use problems like this to introduce new ideas, just for fun. So what does this problem say? It says that we have this kind of a solid object, and it's given that there are certain numbers that are written at the vertices of this object. It's a solid figure. There are some numbers written. Of course, 2 of the numbers are actually written down. The remaining numbers, they have not written it down. Now, it's also given that the sum of the numbers at the 3 vertex of every triangle, sum of numbers in a triangle. So let's suppose you have this particular triangle. Then the sum of these 3 numbers, this one is not written down yet. The sum of the numbers in the vertices is equal, is a constant. So suppose it's 15. If you take the 3 numbers in the 3 vertices and add them up, for this triangle it's 15. If you do it for this triangle, it would also be 15. For this triangle, it would also be 15. For every triangle, if you add up the 3 vertices number, the vertex numbers, it would add up to the same thing. So that's the magic sum. The vertex numbers add up to this same magic sum. The question is, what is the sum of the numbers in the 5 vertices? If you add up all the numbers in the 5 vertices, what are the sum of the numbers? So to do this, of course, you don't need graph theory, but I will introduce it anyway. And remember, this is for young kids. So what is a graph? A graph has a bunch of vertices, like corners, and there are a bunch of edges. Edges are like straight line segments connecting vertices. Okay, so a graph has vertices and edges, and the main idea of a graph is the key information is adjacency. Adjacency means which vertex is just beside which one. So for example, this vertex and this vertex are adjacent, but this vertex and this vertex are not adjacent. So if there is an edge between the 2 vertices, then they are adjacent. If there is no edge between them, they are not adjacent. Now, turns out graphs have many beautiful properties, and they can be used to model the world around us, at least some part of the world around us. For example, think about railway network. You can imagine every station as a vertex, and if 2 stations are connected by a railway line, so railway tracks, you can think about that as an edge. If you think like this, then the entire railway network is actually a graph. Remember, this is not the coordinate geometry graph. This is the graph containing vertices and edges. So if you are able to understand the mathematics behind graph theory, you might be able to run railways efficiently. Okay, so there is a lot of connection between this abstract part of mathematics and real world applications. In fact, I remember one of the students at Cheenta went on to use graphs to describe knowledge and write a research paper on it. It was very beautiful. Maybe in some other video I can talk about it a little bit more, but just a hint that many real world problems are actually modeled by graph theory. So you can think of this as a solid object, which it is. You look at it, it looks like a solid object. But you can also think of this as a graph. Okay, does that help you in any way? Well, yes. Basically what it says is that every circuit, here every circuit is, like the smallest circuit is a triangle. Circuit means it's like a circle. You can just go back to the starting point. It's the smallest undisturbed circuit is a triangle in this particular picture. Of course, there are bigger circuits like this, which are not triangles, but I'm talking about circuits which are the smallest ones. So in this case, the smallest circuits are triangles. And it says that each circuit can be given a magic sum number. And what is the magic sum number? The sum of these three numbers at the vertices. So what we will do is, we will take the magic sum as x. So sum of the three numbers is x. So therefore, this one is 1, this one is 5. So this particular one is x minus 6. Right? So this one has to be 5. Because the total sum, 1 plus 5 plus x minus 6 is x. And that's what it is. Every triangle adds up to x. Okay? But see what we just did. We completed a triangle with all the three numbers at the vertices. So 5, 1, 5. So now we know what the magic sum is. It's 5 plus 5 plus 1. That's 11. So the magic sum is 11. So now I'll give you a little challenge question. What is the sum of the numbers in all the 5 vertices? So figure out all the 5 vertices. Give the sum of the numbers in the comment section. Let's see if you can do that. Also, if you are a kid in 6th grade or below, and if you are able to write down a detailed solution of this problem in the comment section, then we may invite you to present it in our YouTube channel. And we can also give you access to our Junior Math Olympiad program for 2 weeks. All the best. I'm sure you can do it. Keep on doing good mathematics. I'll see you in the next one. Bye.